Your choice of material at the outset of your project can have implications for both the printing process and for your final product. There are dozens of materials available for FDM printing alone, and the sheer number of options can at times feel overwhelming. Instead of presenting a laundry list of materials for you to memorize, in this video we present an overview of some of the most important properties to consider when choosing a material for your project. As an FDM operator, you will be working almost exclusively with thermoplastics. Thermoplastics are a class of plastics that soften and become viscous as they are heated. They can then more easily be shaped into new forms and will re-solidify as they cool. Not all thermoplastics are created equal, however, and they encompass a diverse range of properties, which can include mechanical properties as well as visual quality and ease of use. Mechanical performance encompasses the set of properties that concern how your part behaves when forces are applied to it. Chief among these properties are strength and flexibility. Materials can be classified both in terms of tensile strength and impact strength. Materials with high tensile strength can withstand being pulled apart by a large amount of force, while materials with high impact strength can withstand being struck by large amounts of force. Materials with high tensile strength do not necessarily have high impact strength, and vice versa. Thermoplastics range from polycarbonate and nylon on the strong end to materials like polypropylene on the weak end. Common materials like ABS and PLA fall in the middle of the range. Mechanical performance is most relevant when designing parts for engineering applications. Flexibility governs how easily a material can be deformed without damage to the structure. One of the most flexible materials is TPU, which has properties similar to rubber. Other materials such as ABS, PETG, and nylon are somewhat flexible. Among the most rigid materials are PLA and HIPS. Visual quality encompasses the final product's finish, either matte or glossy, as well as the level of detail possible with a particular material. Materials like ABS have a matte finish, while materials such as PLA have a slightly glossy finish to them. Certain materials are known for being more difficult to work with than others. The easiest materials are accessible even to those new to 3D printing, while other materials may present more of a challenge to print with and may require a significant amount of troubleshooting to print with a good outcome. Among the easiest materials to print with are PLA, PETG, ABS, and nylon. Materials such as TPU, HIPS, polycarbonate, and polypropylene are more difficult to work with due to issues such as stringing and oozing. Many materials, including ABS, PETG, and nylon, require a heated print bed in order for the material to adhere to the build plate. Other materials, notably PLA, do not require a heated bed for printing, though a heated bed can still make the material easier to work with. Most FDM materials are not inert and will degrade if exposed to environmental factors such as heat, humidity, and ultraviolet light. This has implications both for storage and for the durability of the final product. Materials such as PLA and PVA are sensitive to moisture and must be stored in sealed containers to prevent them from degrading. PVA will dissolve if it comes into contact with water and can be used as a water-soluble support material. PETG and polypropylene are both moisture resistant. Other materials will degrade if exposed to high temperatures. PLA, for instance, is not heat resistant and will fall apart if placed in a dishwasher. Materials such as nylon, HIPS, and polycarbonate, on the other hand, have high heat resistance. Most FDM materials will become brittle if exposed to ultraviolet radiation for extended periods of time, such as when placed out in the sun. Some materials, such as ASA, are resistant to UV radiation and are well suited to outdoor applications. If your final product will come into contact with chemicals, you will want to choose a material that is highly resistant to chemicals. The best choice for this is PETG. Certain materials are extremely sensitive to specific chemicals. For instance, ABS is highly sensitive to acetone and will dissolve if it comes into contact. This property can be exploited during post-processing, where acetone can be used to smooth ABS parts. Similarly, HIPS dissolves in limonene and can be used as a soluble support that can be easily removed with an application of the chemical. Certain materials are generally safer to work with than others. Additionally, certain materials are unsafe for certain applications, so care should be taken to choose safe materials for the application at hand, especially for food or biomedical applications. Some materials, such as ABS and nylon, produce fumes while printing. Care should be taken to use these materials only in well-ventilated spaces. PLA is one of the safest materials to work with. Not only does it not produce toxic fumes while printing, but it is biodegradable and food safe, provided proper care is taken to keep the process clean and to seal the finished part. For food applications, however, PETG is the best choice, as it is sterilizable and can be washed in a dishwasher without deteriorating. ABS is generally unsafe for food applications. Another important factor to consider when choosing materials is cost. Materials vary greatly in their price. ABS and PLA are some of the least expensive materials, while polycarbonate and polypropylene are some of the most expensive. You are not expected to memorize the properties associated with every material available for 3D printing. Instead, focus on remembering the attributes of the most common materials. At the very least, you should have a familiarity with PLA and ABS. Both PLA and ABS are inexpensive, easy to use, and relatively strong. Both make good all-purpose materials. For other materials, you can easily look up tables of their properties. With the information presented in this video, you should now have a better idea of which properties to consider when choosing a material for your project. Remember, there is no need to memorize all of the properties of each type of material. There are many online resources available to help you make a decision. From all of us at Fab Lab Hub, thanks for watching.